In this video, we're going to discuss deleting an interior node from an existing linked list. In other videos, we have discussed the three basic cases, which are deleting the node that is at the front of the list, deleting the node which is the last one on the list. In this video, we're going to be talking about deleting a node that is not the first one, not the last one, but it has a position somewhere in between. Let's start by reviewing the basic implementation of the linked list. It's a single linked list where every node has a reference that refers to the next node. There is an external reference called front or head that tells us the address of the first node, and the very last node has a reference called next that is being set to null. So what is important to realize is that in this typical linked list, we can only traverse the list going from left to right, from the first node to the last node, because all the references refer to the next node, they don't refer to the previous node. We're talking about deleting an interior node from a basic implementation of a linked list. Because we can only traverse the list from to back, or beginning to end, or left to right, we're going to need two external references in order to find the node that we want to delete and then delete it from the list. So there is going to be an external reference called previous, and that one we are going to use to refer to the node that precedes the node to be deleted. In other words, the node that is before the node to be deleted, and that's called previous. The second external reference is going to be called current, and current is a reference that refers to the node to be deleted. Let's take a look at a picture and realize why do we need these things. So here again is another example. This is a linked list of integers, and let's assume that we want to delete 99. That's the only interior node that we have. So in order to delete 99, what I need to do is to take this reference, which is the next reference inside the node that has value 12, and change its value. Change its value so that it refers to the node that is currently being referred by 99. 99 refers to 37. So what I want to do is take the next field in 12 and change its value so that it refers to 37. So I am bypassing 99. I am bypassing the node to be deleted. I need to know then two things. I need to know first if I have a match, right? In order to delete a node, probably I'm going to be given a value. Well, what is the original linked list doesn't have that value. Then we don't have to delete anything. So the first task is to find a match to see whether or not the value that I want to be deleted exists on the list. Okay, now if the value exists, then a node is going to have that value. So I need a reference to that node. That's going to be the current reference, right? So now I know I need to delete this node. And as we just discussed, I need to change the value of the next field of the node that is in front of it, that precedes it. That's what I'm going to use, previous. So you're going to see when we discuss the code that the current reference in this case will be referring to 99, and the previous reference will be referring to the node before, which is the one with 12. One more thing is what happens to the node that has 99. The node that has 99, Java takes care of it by executing what is called an automatic garbage collection. In Java, a node without a reference is permanently lost in the sense that there is no way to reverse the operation. So once I change the value of this next field in 12 to refer to 37, there is no reference in the linked list referring to 99. So this is what in Java is called garbage. Why is it garbage? Well, because we have data like 99 and a field called next stored in memory, but we have no way to retrieve that information because we don't know where that address is located. There is no reference to it. So we cannot retrieve it to display it, to modify it. So we are wasting memory because the data is stored in memory, but we cannot make any use of it. So it's what we call garbage. Another word for this is a memory leakage, okay? We are storing values in memory which we never are going to use or retrieve. So Java recognizes that, and automatically, without us having to provide a statement, it says, oh, you release these addresses in here, you don't need that data, and then what it does is to make those addresses and that memory available for other operations. It's called automatic garbage collection. So let's talk about the steps to delete the node and use a different graphic. So the first step is to traverse the list okay, to find the node that we want to delete. Again, most of the time we're given a value, so we need to determine whether or not the value is there. And if it is, where, right? So we're going to use then previous and current to do that. And remember, we're going to use previous and current from the very beginning, traversing the list, inspecting one node at a time, looking for a match. Previous and current are going to be exactly one node apart from each other. So let's take a look at this picture here. This is a different linked list where we have 3 nodes. And we decided that we want to delete the one that has value 14. So we need to first search for 14. We don't know where it is on the list, so we're going to use previous and current. Once we find 14, then it will be the case that previous is going to be referring to the node that precedes the node to be deleted. So previous referred to the node that goes before the node to be deleted. So previous referred to 12, 12 precedes 14. What about current? Well, current is going to refer to the node to be deleted, which is 14. So once we have those two, then we can manipulate the next reference in the different nodes and then bypass 14. In other words, take the next in the node that has 12 and make it refer to the node that has 24, bypassing 14, and then 14 is not part of the list. So let's take a look at the code that does those things. Let's talk about the value that I want to delete. There are many different ways of implementing a method that deletes an interior node from a linked list. So this is not the only implementation. This is not the most common implementation. This is just simply my implementation of a method that will delete a node in an existing linked list. And the way I decide to implement it is by writing a method called deleteAnyNode that is going to return an address. Okay, what is this going to return? It's going to return the beginning of the list. Because it could be that the value that I want to delete is the very first one. So if I modify the beginning of the list, I need to reflect that. But again, there are many different ways of writing a similar method. And I'm providing a parameter. A parameter in this case is going to be an object of the string class that represents cities, and I'm going to call it city. So in other words, I have a linked list of cities and I want to delete this value that is given to me. First, let me start with finding the node. So I'm going to have 2 references, and as discussed, the names are current and previous, and I'm going to initialize current to front. Why? Well, because in the linked list that we show, we only know where to start with the first node, right? That's the only external reference that we have. We don't have any other external reference. So this first value of current logically should be front. Now, if we need to keep previous one node apart and one node behind at the same time that current, then if current is looking at the first node, my only option to start or initialize previous is to assign null, which means it's not even part of the list. So at the very beginning, current is looking at the very first node, which is the same as what front is referring to, and previous has value null, which means it hasn't referred to anything. Then I'm going to use a while loop because I don't know how many nodes I have to go through. I don't know where the value that I want to delete is located. So in my while loop, what I'm doing is trying to locate a node that has a value matching this parameter. So this is what this statement is doing here. It's saying, let me compare the value that I'm looking for, which is the parameter aCity, which is a string object, with the value at a particular node. And at the very beginning, current is looking at the very first node, getData extracts the value of the first node, and it's going to compare the 2 strings using equals. Remember, these are objects, so I need to use the equals method. I'm not allowed to use the equal operator. Okay? Now, when this statement is true, I got a match. I found the node that has this value. I have found the node that I want to delete. Therefore, I want to negate this condition, sort of like, as long as I don't have a match, keep looking. But as soon as I have a match, then this equals will return true, but because I have a negation, it will be false and the loop will stop. I need a second condition to make the loop work. The second condition is we're going to traverse the list, we're going to inspect node by node, and we're going to find no matches. So after inspecting all the nodes on the list, I should stop and then conclude that the value that I want to delete, given as a parameter, is not present on my linked list. So I need to have this condition. And notice that is current, get next, not just current, different than null. And the reason for this is I want to stop at the very last node on the list, not after inspecting the last node on the list. What happens as long as this loop keeps executing? Well, as long as the loop keeps executing, what I need to do is traverse the list. Okay, I need to keep moving down the list, trying to find a match, and I need to, therefore, update the values of previous and current, which are my two external references. So every time that the loop iterates, what I need to do is to advance to the next node. This is a two-step operation. The first step is to make previous identical to current. So after this statement, the two references are looking at the same node. But the rule is to maintain them separate and exactly one node apart from each other. So after I do this, so previous is advancing, is moving to the right to have the same value of current, then I need to move current one node to the right. In other words, assign to current the next reference. So at the end of these two statements, I'm moving previous and current, but I'm keeping them one node apart from each other. Eventually, this loop is going to stop. But I have two conditions that will make it stop, either because I found a match or because I inspected every node and the value is not present on the list. So I need to decide which of those two conditions made me stop. And I'm going to ask, did I stop because I found a match? If I stop because there is a match, then I know that I need to delete a node, and I know where it is located because the reference current is looking at it. So my loop will have stopped because this condition became false, and became false because I found a match. So if there is a match, this condition then is true. Current is looking at a node that has a data that matches the data that I was given to be deleted. So what do I need to do? Well, I need then to bypass the node. How do I do that? I need to change something in the previous node. I need to change the next reference of the previous node, right? So what I need to do is to take the next reference and make it refer to this node. But how do I find this node? Okay, that's the second part of the statement. Oh, that's current.getNext. Current, we know, is looking, referring to the node to be deleted. I need the node that goes after, so which is getNext. So when I say previous set next, it's going to change the value of this reference. Change it to what? Change it to current getNext. That gives me this node because that's the reference that refers to 24. So indeed, I'm bypassing, and the next will point to the node that goes after the node to be deleted. So that's why that statement is there. So again, I need to do this because there are two conditions to make the while loop stop. I need to make sure that I'm stopping the loop because there is a match, and then reallocate the references. Now, if this statement is false, what does it mean? It means that the while loop stopped because of this condition, meaning I traversed the list and there were no nodes matching the value that I want to delete, in which case I don't need to do anything, right? Because there is no node to be deleted. What about the rest of the code? Well, there are some special cases. As usual, every time that you try to delete something from the list, you need to make sure that the list have at least one value. In other words, if the list is empty, if front is null, then there is nothing to be deleted. So I'm going to return null. The other special case is that the node to be deleted is the first one, in which case there is no need to traverse the list. There is no need to have this while loop executing. I can simply just bypass the first node. So deleting any node is equivalent to deleting the first node of the list. So I'm going to test and ask the question, is the first node data matching the data that I want to delete? And if the statement is true, then I need to bypass the first node, but that's very simple. I assign to front the node that comes after. Okay, so very important for you to realize that these two basic cases not only are needed, but it will make your code more efficient. Finally, whichever node gets deleted, remember I wrote this method by returning a value at the end that is the value of the first node in my list. So what I want to do is return front. So this will conclude the presentation on how to delete an interior node from a linked list.